So our next speaker is Adam Naids. He's going to be discussing Artemis geology tools that are under development. Adam, please take it away. Adam, if you're speaking, we cannot hear you.
Hi, how's
that? Say again?
Can you hear me okay?
Yes, we can hear you now. Great, thank you.
All right, you got it. Hi, everybody. My name is Adam Naids. I'm the Deputy Project Manager for the Artemis Geology Tools. Also, Heather Bergman is here. She's our project manager, and on behalf of us and just the whole team, I'm really excited to share what we've been doing over the last year and a half. Next slide, please. All right, I'm here just for some simple things here for you. One is just to let you know that there is a team creating geology tools for the moon right now. And I want to status you on what we've been doing and talk about some other stuff. A lot has happened since I talked last year at this workshop. Next slide. Okay, so this is a one-pager that tells you kind of what we've been up to. So in fiscal year 20, we started to work on 8 tools. We got started really quickly soon after kind of the Artemis program started to take hold. And we started to work on tools that we knew we were going to need at some point based on Apollo and research there. So we took these 8 tools to a preliminary design review level in 1 year. It was a lot of work with a lot of uncertainty. Really proud of the team who helped make that happen. And in fiscal year 20, we started development of some additional tools, 8 additional tools, as you can see out there. Some of them were using.
You might be interested in these talks.
Sounds like we have an open mic
On the
there.
phone. Oh, sorry. Well, I was just going to say, you might be interested in these talks.
There we go. Go ahead, Adam.
Yeah, thank you. So we've that's what we've been up to this fiscal year, and we just had a requirements review back in March, about a month ago, for these 8 tools. So we're making a lot of progress through our project development life cycle. And then we've also worked on a phase 3 SBIR contract with a commercial partner that has been working on these technologies for us for a while to make these vacuum sealed containers, which are obviously very important to return the volatile samples that you all are interested in, and then a powered core drill as well for getting those deep core samples. So this is just a snapshot of some of the work that we've been doing, that we've progressed through these big milestones, but there's other tools and equipment that we've been working on as well that are at varying levels of fidelity. Next slide. Notional concept of operations. So this is pretty straightforward, but just making sure we're on the same page. We're going to fly our tools to the moon. We'll either fly them on HLS, maybe we'll fly them on clips, maybe it'll be a combination of those options. All of that has been pursued and talked about. We'll fly a contingency sampler, and we'll take that sample as soon as we can on that first EVA. That was also listed out in the science definition team report as really important to do. The crew will have tools on the suit itself. We're trying to fly a tool belt that we can connect tools to, along with carrying some tools on the legs of the suit as well. And the goal there is to make the crew as efficient as they can and to enable them to do end-to-end sampling operations by themselves. And so that just provides additional efficiency to bring back more samples for you all to study. We'll take the samples, we'll put them in sample containers, and in various stages, we'll get those back to Earth. We'll have special methods for capturing volatile samples, preserving them, and we'll do this all in collaboration with the curation teams to make sure we're documenting everything the way that we need to do that. And then we'll bring everything back either through HLS, Gateway, Orion, and then back to Earth to the curation team, which will then be delivered to all of you to study and tell us what we've learned. And then all the tools are just single mission focus only, and they'll fly for one mission. We'll leave them there. That's so we can bring back more samples for everybody here. maybe on sustained missions with the base camp, we could potentially reuse tools, but we'll talk about that at a later time. Next slide. All right, some major updates. We've been prototyping a lot. So we've been 3D printing, we've been making metal prototypes, we test, we prototype, we iterate, that's our culture, and we move really, really fast to try to do that and test them in various facilities. We do simulant testing in the simulant development lab here at JSC to make sure that our mechanisms can hold up to the lunar dust, and that is happening often. We've been working with the HLS partners when we were able to do that to talk about interfaces that were required. We've gotten really smart on contamination control and contamination knowledge by talking to some of the experts in the field, and we drafted a preliminary contamination control plan, which is really just an outline at this point. There's a lot of open questions here, and then we've been working with folks to try to resolve that and understand what those requirements are, and we're making really good progress in getting there. And then you heard Sarah talk earlier about the CARI rapid response team, and we were definitely one of those engineering teams that were nudging there to try to get some responses. So we're really happy that we were able to get this team put together, and we've submitted a few requests already, and are supposed to be hearing back pretty soon on those. So we're really excited. Those requests the topics were around what materials we can make our tools out of so that we don't contaminate the samples. And so we'll be utilizing CARI and that team regularly, I'm sure, over the coming months and years. Next slide. All right, here's a really cool picture of some of our prototypes. This is not everything, but it's a good amount of them. We cleaned them up really nice for these pictures, but they have been getting real dirty out during our testing. So this is, we're really proud of the work that we've done. We really have flight quality tools that we are getting really close to being ready to fly to the moon. It's an honor to be able to work on these for you all and for everybody else. Next slide. I talked about testing a little bit, so we've been doing a lot of these testing. A lot of the early testing, we just decided to make some quick concepts that helped inform what the requirements need to be. Requirements are really important to us as engineers, and so that was very helpful. And then these tests have been really good to help us understand how to do science-driven EVAs again. We have a whole new generation of people. We're trying to learn this, and so it's been a very good training exercise just to get out there, do these tests, and work together. And it's been really fun. It's been a really fun activity to do that. And then we've also had a chance to look at the lunar lighting environment on the South Pole. It's definitely a little bit unique. So we've taken very small steps at this point in time to just try to understand what that's going to be like and the challenges associated with it. I mentioned this was an integrated team, so we have people from operations, we have astronauts, we have people from the science world, photo TV, lighting, the spacesuit team. We have this awesome integrated joint EVA test team that is taking these steps forward. All right, next slide. There's a couple other pictures. So since we aren't able to go out into the field where we would all like to be to do these field geology EVAs, we've been using the rock yard, which is at JSC, and we were able to figure out how to do that even within COVID with some protocols. And so we don't have spacesuits out there, but we have developed a whole bunch of mock-up equipment that helps us simulate what they would be doing and learn by doing. Let's go to the next slide. Here's a couple other pictures from our first nighttime eval or dark ops eval. So we learned a lot by just going out there and trying to take pictures and take samples and do all the documentation we need to do in this environment. Our level of fidelity is not super high right now, but we're taking small steps forward each time we get out there and test. Next slide. All right, so there's some upcoming milestones for us. So this is kind of where our schedule stands at this moment in time. We have a preliminary design review for the tool carrier at the end of the year. And then we have a critical design review for a whole bunch of tools next year, as early as March. That's a big review for us that we do right before we start to build our flight hardware. So we're really close to being ready to do this. And so we're getting there, and we'll see how things unfold over the coming months and years. Next slide. And then there's a whole bunch of other tools and equipment that we know will be made, some of which our team will make, some of which other people will make. But we're aware of this, and we're looking forward to working with everybody and bringing them into the fold as we move along, and all try to figure this out together. So again, thank you for your attention, and excited to answer any questions that you have during that time frame. And 3, 2, 1, back to you.
Well done, Adam. Thank you very much for this exciting developments on these tools and equipment. That's very important to get our astronauts duly suited up